And we have different types of triangle. We have a triangle in which one of its angle is a right angle. That type of triangle is called right-angled triangle. Right-angled triangle. We also have another one in which two out of the three sides of the triangle are equal to each other. So, two sides are equal, two angles are equal. That type of triangle is what we call an isosceles triangle. We also have another type of triangle in which all the three sides are equal. That type of triangle is what we call equilateral triangle. Equilateral triangle. Then we also have a triangle in which none of the three sides are equal. That type of triangle is what we call scalene triangle. Now let me bring something up here. You can see that the mark here is similar to what we have here. What this means implicitly is that this line is, okay, let me just, if this is A, B, C. Are you getting it now, of this triangle? The side facing A is facing angle A, is side A. The side facing angle C is side C. The side facing angle B is side B. Are you getting it now? If you look at this, you can see that I'm putting similar sign in side C and side B. What this means technically is that line C has the same length with line B. Look at this. If this is ABC of an equilateral triangle, this will be B, this will be A, and this will be C. Since we are having three marks of equal pattern, what this means technically is that all the three sides are equal. Then, look at the scaling triangle. I put just one mark here, 2 here, 3 here. What this means technically is that none of the three sides are equal. Is that got to now? Now, to solve problems, mathematical problems related with triangle, we can employ three methods. The first method is what we call the Pythagoras theorem. Pythagoras theorem. The second method is what we call the sine rule. Then the third method is what we call the cosine rule. But where do we make use of the sine and the cosine rule? We make use of sine and the cosine rule for non-right angled triangle. Non-right angled triangle. Are you getting it now? What do I mean by non-right angle? This isosceles, equilateral, are scalene. None of the three triangles has a right angle. So, I classify them as a non-right angled triangle. Is that good to now? But this one is having an angle. One of its three angles is equal to 90 degrees. This is a right angle triangle. For a right angle triangle, we make use of what? Pythagoras theorem. Now, our business for today is going to focus on how do we solve problem related with right angle triangle. If we have a right angle triangle like this, this is a right angle. Are you getting it now? This longest side is known as the hypotenuse. I hope that is clear. Now, opposite is not fixed, contrary to some people's opinion that you just take a side to be opposite. No. What determines our opposite, it depends on where we are having our acute angle, one of the two given acute angle. Let's say we are given our theta to be here. This is right angle, this is acute angle. You will now look for the side that is opposite to this, that is facing this directly. This is now going to become our opposite. Are you getting it now? And like an adage in Yoruba land, Yoruba will say 3 people are eating. One of them say, why are you rushing the soup? The second say, oh, thank God you are watching him. Who are they referring to? Automatically they are referring to the third person, right? Now we need 3 sides. We need to know 3 sides. We've known that the longest side is the hypotenuse. The side facing the acute angle is the opposite. Automatically the third side becomes the adjacent. Is that got to now? Now Pythagoras theorem dictates that hypotenuse square equals to opposite square plus adjacent square. Meaning that we are going to employ Pythagoras theorem if we have, let's say, this is 5, this is 4, and we have our theta here. Then we have x here. So to find x, what we are going to do is that hypotenuse square equals to opposite square plus adjacent square. What is the square of the hypotenuse? 5 square equals to, our opposite is what? 4 square plus our adjacent is unknown, x square. Is that got to now? Then we are going to have 5 square minus 4 square equals to what? X square. Is that got to now? So 5 square minus 4 square, you can simplify it in 2 ways. Let me bring a method. We call it difference of 2 square. X square equals to 5 square minus 4 square, right? You can have 5 minus 4, 5 plus 4. That's what we call difference of 2 square. Then our x square become 5 minus 4 is what? 1. Bracket means multiplication, right? 5 plus 4 is what? 9. X square equals 9. Then x equals to square root of 9. X equals to 3. And if you don't want to use difference of 2 square, where you have x square equals to 5 square minus 4 square, x square will now be equals to, what is the square of 5? 25. What is the square of 4? 16. Then x square will now be equals to 25 minus 16, 9. X square will be equals to 3. That is square root of 9. That is when you have a right angle triangle where 2 of its 3 sides are given and you ask to find the third side. The question asks us to find angle theta and x. Is that got to now? So with this type of question alone, it is going to lead us to every method we can employ when dealing with right angle triangle. Our first business here is to find x. How do we do that? We make use of Pythagoras theorem, right? So in that regard, we say x squared equals to 5 squared plus 12 squared. X is our hypotenuse. 5 is the opposite. Why? It is the side facing angle theta. Then 12 is the adjacent. So our x squared becomes 25 plus 144. Is that clear? So our x squared becomes 169 then our x equals to square root of 169, our x equals to 13. So meaning that this x equals to 13. I hope that is clear. So now, how do we now find our theta? That's where the business lies. When you want to find any angle in a right angle triangle, you now refer to this formula. Sol, ka, tua. The meaning of sol, ka, tua is to find sine theta equals to opposite over hypotenuse. To find cos theta, it is equals to adjacent over hypotenuse. To find tan theta, it is equals to opposite over adjacent. Now in that regard, we can use any of these three formula to find our theta here. Let's use sine theta to find, and we use tan theta to check if our answer is actually correct. Our sine theta equals, what is the opposite? Our opposite is 5. What is the hypotenuse? 13. Is that good to now? So our sine theta equals 5 over 13, right? What is 5 over 13? Pause. So 5 over 13 is equivalent to 0.3 what? 38. Our theta will now be equals to sine 0.38. If you want to press this on your calculator, you press shift before pressing sine. So you now type 0.38. 22.62 degree. Are you getting it now? If you actually want to check if this is correct, we can also use tan theta. What is tan theta now? Tan theta equals to opposite over adjacent. What's our opposite? 5. What is our adjacent? 12. Is it? So theta will now be equals to arctan 5 over 12. That gives us what? It will also give us 22.62 degrees. Now let me explain something here before we end this class. What is very important here is for you to get your opposite and your adjacent right. The secret is that if your angle is here, your opposite is here. Let's say we have another angle that is alpha here. The opposite of theta is 5. The opposite to alpha is 12. So if the opposite to alpha is 12, automatically 5 will be the adjacent to alpha. If the opposite to theta is 5, automatically 12 will be the adjacent to alpha. But hypotenuse still remains the same. I hope that information is clear. So that is the secret in solving right angle triangle. In subsequent episodes, we are going to explore other methods of solving triangle, which is the sine and the cosine rule. Thank you.